Hello, this is Steph. Welcome back to my channel. Sorry again with this long absence. This is the longest absence that I've ever had since the foundation of the channel. There are a lot of things that I went through, and I didn't have a long period of time in which I could develop videos. And if you like the content that I've done so far, please like, share, and subscribe, and hit the notification bell to get notified about the next videos. And today we're going to deal with Python and FFmpeg. So we are going to check some packages, one of them in particular today, that is PyAV. And let's see what can it do, and let's see what are the potentialities and the capabilities of this wonderful package if you would like to program in Python and you want to manipulate and do something with videos, images, audio, multimedia data in general. And so now it's time. We have Windows, and so we can get started. Okay, first of all, the thing that we're going to do is to install Anaconda or Miniconda. Usually I'm more prone to use Miniconda to work with Python environments that are essentially some environments that are independent from other environments you would like to create in the future. And you can install any packages that you want. You can install any program that you want, and then if you would like, you can remove it completely. You can get rid of it as soon as you want. And so now we're going to see first of all how to install Miniconda. So it is very easy. So we have the page right here. I'll put in the description, and here you have according to the operating system they're going to use. In this case, Miniconda 3. Windows 64-bit is the one that is of our usage. So here it is downloaded, and you can click and follow the instruction, and it is installed. So this is the first step that we can get through. Once it is installed, I think that you can do is to go here and check Miniconda. You have the Anaconda prompt. Since I'm using the Windows terminal on Windows XP, I have already my Anaconda prompt right here. So I create a new setting with Anaconda prompt ready right here. So I will open it. And here we have the base environment open. The base environment is something that you don't have to touch. The only thing that maybe you can do is Conda, update Conda to see if there are new packages that needs a refresh and an update, but among the rest, you're going to create environments that you're not going to touch the base environment. So here it says I have to update. After that, I don't touch anything anymore. The thing I'm going to create right now is a new environment using the command conda create. In this case, got to put a name, so -n or -- name, so it's the same. In this case, I will call it FFmpeg -python. If you would like to specify the version of Python you would like to use. So in this case, we can use the latest available. So in this case, we don't do anything. Otherwise, you can say Python equals to the version you would like. So for example, if you would like to install the version 3.8.10, there's something you can do. Otherwise, we leave it like this, and then later with another command, we install the latest version of Python. So at the moment, we create, yes, I've already created this thing before, but I deleted everything. So I'm going to create the environment anyway. Yes, I proceed. And at the moment, my environment is there. So if you like to see all the environments you installed. I have other things because I'm making other experiments. You got to check the command conda and list. So here we have a bit of them, and so this is repeated, but it's one environment. Here, this is the environment we just created, so this is one that we can use. To activate the environment, we can go to conda, activate, FFmpeg-Python. And now, as you can see, we have the FFmpeg Python enabled. The thing that we need to do is to install the version of Python you would like. So in this case, conda install Python. And here we have the package installed. So here we have all the necessary things to work with Python and other things. So you have pip, you have wheel, you have the zlit, and so everything is here. The version of Python that will be installed is 3.11.3 as to what the video is recording. So the day of today, this is the latest version available. So for us, we don't care so much about the Python version. So don't take something that is too old, but in this case, we take the most updated one. We wait until the installation is done and everything is done. So now the thing you would like to do is to install the necessary packages. The necessary packages that we need to have. So we need PyAV and also another reference that is PIL. So we use a pillow to install it. So here we have pip install. We said PyAV, so in this case it is AV, and also the other package that is a reference that is always taken as in consideration, that is pillow. Remember, with the uppercase P, pillow, and then we go. So now I've already installed it in the past, so there is no process of downloading. It takes the cache version, and now we are ready to go. You would like to go on from this moment. Now we pass to Visual Studio Code. Okay, so I moved myself on the right part of the screen just to see what is going on with the left part. Then I'll move back and forth if it's the case. Anyway, here what I would like to do is to create a Jupyter notebook file. So I'm going to create a new, so this is a new folder within Visual Studio Code. I open a folder that is empty. I would like to create a new file that is called PyAV_demo.ipynb. And here, if you didn't select any kernel, you can, here at the top right, you can select the kernel. It will open a dialog like this, Python environments. In this case, you can select the environment that you just create. If you would like to create a new one, you can do it within Visual Studio Code, but FFmpeg Python is the right one. Okay, so now we are ready to rock and roll. And the first thing that we need to do is to import AV. So AV will let us open the new, the library, the package that we've just created. We just installed. And now the next step is to import the video file. So in this case, the video we are working at is the old Big Buck Bunny that we still have for a long time, that we usually use for our tests. Here what we can do is to open the file. So here we take a video path equals to, and we take the path to the video by taking the shift key and right click, copy as path. We take this right here, and then we change the backslash with a double backslash, otherwise it will be considered as an escape character. or if you would like, you can take the /. If you are on Linux, it will be taken by default, the /. And then in this case, we can go on and it tells us to install on the first instance the kernel, and so we wait until the kernel is installed, and now we can start working with the first. Okay, here we go. So after the kernel has been installed and running, we can go to the next step. So I open a new cell. Here we have the second step, that is opening the video file. So we use a container that uses the function av.open, and here we use the video path this way. We see also what the container actually contains, and so it is a reference to the input file, so with the av.input container. Then let's open another cell, and the other thing that we need to do is to open the stream. So we have the stream equals to the container dot streams. So here it contains all the streams that we have here, and as you can see, Visual Studio Code suggests the type of stream you would like to take. In this case, we take video, and since we want the first video in the sequence, we have the video 0. Let's see also what the stream contains and what can it tell about the video itself. It is a VP9 with a resolution of 1280 by 720 YUV 420p. So it tells also the color space and the subsampling this video has. Cool. Then we open another cell, and in this case we can take other information. For example, the average frame rate. So the average, say FPS, or let's call it FPS only. Here we can get the stream directly as the average rate, but there is a problem. Take the FPS like this, it will be expressed as a fraction. So there is a numerator and the denominator. So we would like to have the number directly as a float, or if you would like to approximate to an integer. In this case, we know that it's an integer. We can take the integer, but let's keep the float. We can force it to be a float. We can cast it to a float. We have 24 frames per second. And a thing that we can do is to extract all the frames. But all the frames is a bit too long, and I would like to take all the frames which are in a second. Sorry, every frame that are at the beginning of a second. So how can we do it? Since we want a frame every second, we can take all the frames in the video and see which are at the multiples of the frame rate. So we can go to 4. Here, a thing that we can do is to extract the frames in this way. 4 frame in container.decode. Here we can take the stream and then do all the stuff. But a thing that I highly suggest to do as soon as you have a numerable data structure, like the sequence of frames that we have in a video, we can do is to use the enumerate function. So here we have the index frame in enumerate this container.decode stream. And so in this case, we can take the frames which are in the at the second. So if we make if frame dot if index divided, so it's modulo FPS is equal to 0, so they are at the thing, we can say frame dot to image. In this case, we're going to decode the image itself, but we want to save it. We're going to save it, let's say, in the same location where the program is. So we can take an F string to say frame index.png. So in this case, if you would like, let's see if this works in this way. And the video is 12 seconds long, so we should have more or less 12 frames. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 frames. And as you can see, we have all the frames 1 per second. Cool, as we wanted. Next, a thing that we can do is one of the first things we usually do with FFmpeg is to copy stream a video from an input source to an output source. So now we have still the video path. So if we make, so we didn't reset anything. So this is the input one, and we would like to open an input out of the string that we just opened. We can also recycle the thing that we had before, but just to have the thing sorted, the thing that we can do is something like this. So we open the video with the video path. Then we open the output. Output can be something like av.open, and you can say video path, something like f, an f string, so video path. We can say remuxed dot, let's say AVI, we want an AVI as output, and the thing that we can do is to open the input and the output stream. So input stream is equal to the input dot streams, as we did before, dot video 0. In this case, we have also the audio. So I think that what we would like to do is to take care of it. And in the output stream, we would like to input.streams. Here in this case, since it is an output, we got to output dot add streams, and we want to add the configuration of the stream as it is in the input stream. So it accepts the field template. In this case, we have the input stream as our input. What we would like to do now is to open a for cycle. So there's in this case, we can open the thing right here, and here I think there is a problem with the output file. And yes, so I think that is not working here is that we got to put this in write mode. So remember here that the open must have in the output file the W that says write mode. And here we don't have add streams, but we have add stream. So live debugging, cool. Good, so now we got to open a for cycle, so for packets. So this is the packet they want to put in input stream. Sorry, input dot demux input stream. So this will take every packet from the input. So first of all, we'd like to print which packet I would like to put in. And for any kind of packet that the demuxing generates, we would like to discard it if we like. So if we had packet dot dts is none, we are going to continue. We don't want this kind of data. And we would like to assign the packet that we have at this moment to the new stream we're going to create. So the packet dot stream is equal to the output stream, and then with the function output dot mux, we are going to get, so we've got to insert the packet thanks to the muxing. Then in the end, we should close something that we didn't do before, but we got to close the input and the output. Input dot close, and then output dot close. Let's see. Wait, does this is the same output that is in FFmpeg, and there's the output that is truncated at the moment, but we see in the end that in the output folder we have a big buck bunny remuxed that is more or less the same size as the original file. There is the audio missing, but the video is working fine. So we take a look, it is the plain old video that now is muted, there's no audio stream. Good. Okay, so with this program that we did before, here we don't have the audio. So if I take out the video, and this is the input and this is the output, if we perform so if you play the video, you realize that the video is muted. So here we didn't manage anything about the audio. So how do we manage the audio? In this case, I'm going to copy and paste another file. So I will take this as a basis, and then I will be going on with so let's copy stream, let's call it audio, video audio, video audio. Good. And so now we have the input file and the output file. In the meanwhile, I change a little bit the names just to be a bit more clear. We have these that we can remove, and instead we open a new cell, and here we contain the input video stream and the input video stream. That is, so here in this case, instead of saying this is the first stream that we find in the file, we're going to iterate in all the streams available, and the first that we find out useful, we are going to select it. So here we're going to see, say, next, no, we first, let's build little by little. So we would like to cycle all the streams inside. So we can put s for s in input file.streams. Then we're going to select the type of stream as type is equal to video. And then we're going to select the first. So we're going to take the next function. And so here we take the first stream that is of type video. Okay. We're going to do the same with the audio later. So input audio stream. And here instead of video we put audio. Cool. And then before, so since we're dealing with the video first and then with the audio, we're going to create a new video stream as for the output file that here we have as remux.avi. So here we can get the output video stream is equal to, so before we used the add stream, and here we're doing the same thing. So output, in this case file dot add stream. We're using the template input video stream. So we are going to copy this, and instead of audio we put video, we put audio. Okay. So we have the output input video stream, that is the first video stream in the input file. The audio stream, the input audio stream, that is the first input stream in the input file. Then output, we're going to add a stream that is of type video and the other that is of type audio. So far we are in this condition. Good. Next, what we're going to do is we recycle this for loop, and instead of, so the MOOCs will remain, but instead of putting only the input stream, and before it was only video, we can put the input video stream and the input audio stream this way. So put the input video, the input audio as a list. Then print packet can remain. If packet DTS is non-continue, can remain. So we have all this output that is contained here. And now this is maybe the most difficult part that took me a lot of time to set this. So here packet.stream is equal to the type of stream that we like to see. So the thing is, we're going to loop. If it finds a video stream, it's going to put it in the output or video stream. If it is in the input, the input that we put is of type audio, we're going to output it in the output audio stream. It's very hard to get confused. So here we can do something like this. We can do packet.stream. So in this case, if the type of stream that we have is input video stream, what we're going to do is to take the packet.stream. So the assignment is in the output video stream. And the same thing with the audio. So in this case, we're going to take input audio stream and here output audio stream. Good. The output file .mux packet can remain like this, and this, just to be super polite, we're going to put it in the end. So in another cell, input file.close, output file.close, and that's it. Good. So if we run everything, it should working fine. Let's see. So here we have something belonging to stream 0, that is the video stream, and the other that is the audio stream. So now we should have the output file that has also the audio. Let's have a look. And yes, it has the audio. Good. So let's try if here instead of AV output MP4. Let's have a look. We should have a new file. Yes, MP4 with audio and video all together, stream copied. Good. Okay, so today we used the PyAV as our library to use in Python to manipulate streams, to put in the input and in the output. We put a simple thing, so this is a simple stream copy. So if you would like, you can do some other advanced things like copying, so the recompressing and taking data and taking a look at which are the kind of data that you have inside. So you can do many things with PyAV, and so I suggest you to play a little bit with it. Let's see if in the next video we're going to play even more with this library. At the moment, thank you very much for watching if you reached up to this point. If you didn't do it, please like, share and subscribe and hit the notification bell to get notified about next videos I'll be releasing. And so this was a very hard period. I'll try to make an update as a vlog, so I don't make any promise about anything in the future. So I'll try to record as much as I can. In this month, it was pretty terrible, but at the moment, we are here and try to release a video as soon as it is possible. For the moment, thank you very much and see you next time for other content related to multimedia, but also much more. Ciao!